Hey everyone, so I'm sorry I can't come in today. Got someone here who is not feeling very well, so I had to stay home and make sure she's okay. So I wanted to do a few things to make sure that you guys are ready for the final. I'll try to post a few things today, including this video, but I'll try to post maybe two other things that might help you get ready for the final. So right now, this video, I want to go over some of the expectations and some of the things that you'll see on the final. And then I'll post another video with some practice problems and their worked solutions so you can practice, making sure you understand the math and the equations for the final. So the purpose of this first video is just to go over some of the concepts and some things that you'll see. So first things first. So important notes. All my classes have both seniors and juniors. Therefore, all my finals are happening next week, so June 5th to June 8th. So that's just the way it is. I know some juniors have finals on different weeks, but seniors need to have their finals done by the next week. My final will be partially open notes. What does that mean? That means that you can use the notes that we use in class. You can even come up with your own notes. What it means is that you cannot use a device. You cannot open up your computer in the middle of the final and start Googling stuff, right? But you can use your notes. So, any of the notes that I've given you or any of your handwritten notes on a random piece of paper, that would be acceptable. My final exam was only on the material from quarter 3 and quarter 4. So that pretty much is everything from force, from 1.1 all the way to what we recently covered in terms of energy and work and power. And then another important thing is I'm going to move tables and I'm probably going to have assigned seats to prevent cheating. Okay, so let's just review some of the things, some of the concepts that you'll see on the final. So 1.1, force. So we started off talking about like what is a force, and a force is a push or a pull. So anything that is pushing or pulling is a force. And when it comes to measuring forces, force is mass times acceleration. So if you have a mass, if you have a mass and you're able to push that mass and you're able to make it accelerate, maybe pick it up. Yeah, right. Okay. So Eliza here is pushing on my hand. She's applying a force to my hand. So she's pushing a mass and she's making it accelerate. So that would be a force. A few things to keep in mind, right? If something is accelerating, the more acceleration it has, that probably means the more force was put to it. So that's what the first graph shows. The other graph shows that if something has lots of mass, it's harder to push. So kind of down here, something that has lots of mass would be really hard to push and it has low acceleration. All right. One thing I'll say right now, go back to the other videos, to the original videos to get more details on some of these topics, but this is just supposed to be a quick review. All right, another quick review. Net force. So net force, when forces are balanced, you can say that there's no net force. All right, net force is when if you have a net force above zero or different from zero, that means that one side is producing more force than the other. So in this first picture here, the two sides are equal and there's no net force. We call that a balanced force. If you ever want to find the net force, you take all the forces that you have and you just add them all up. One important caveat is you're only allowed to add them up if they're in the same axis. So anything on the same axis, like the x-axis, you can add them all up. For example, this is all in one axis here. We have people pulling to the left, we have people pulling to the right. So we can add up each individual force and then find the net force. All right, what else should we talk about? Gravity. So gravity is pretty much, obviously, objects being pulled down to Earth. So because it's being pulled down, we treat gravity as a negative number. All right, and it really comes down to mass and the constant for gravity on Earth, which is negative 9.8 meters per second squared. Now, we don't fall towards the center of Earth, right? Something is pushing us back up, the floor, the table, whatever we're on, whatever our objects are on. So there's something called the normal force. The normal force kind of resists the force of gravity. So it's going to be equal and opposite to the force of gravity. And same thing for things that are hanging from a ceiling, like if you have a chandelier or I don't know, whatever is something hanging. It could be a light that you see in the library. Those are being held up by what we call the force of tension. So there's tension in the rope, and or whatever is holding it up, and that's also equal and opposite to gravity. What are you eating? All right, and then the last force that we talked about was the force of friction. So, oh, I'm sorry, I took away. We were interrupted. So force of friction depends on the normal force and the object, the normal force of the object and the coefficient of friction. So what does that mean? Normal force really comes down to, the force of gravity, like how heavy is the object. The coefficient of friction is something that we kind of already know about surfaces, and it's basically just how rough is the surface. So intuitively, hopefully this makes sense. Something that is harder to push might be because it's heavy or because you're pushing it on a rough surface. If you have a heavy object or if you have a rough surface, then you're going to have more friction. And that's really what the equation comes down to. So when you look at this equation, the force of friction comes down to the normal force and some coefficient. And I might give you a table full of coefficients to kind of let you know, okay, so something sliding on ice has a coefficient of 0.1. Right, I know, baby. Hey, we're almost done. Okay. All right. These are things that we talked about recently. Like we talked about the different types of energy, but there are different types of energy, and this is actually a question that you might see or might look familiar because this is actually one of the questions that was on your energy test. Basically, kinetic energy is energy related to motion. Potential energy is energy related to position. Thermal energy is energy related to heat. So those are all things that you might want to review. Again, go back to the original videos to get more details on the particular lesson. But those are some of the key ideas I want you to know. I want you to know the different types of energy. All right, energy conversion. Basic thing you need to know is that energy is never created and it's never destroyed. All the energy in our world and our universe is what it is. It can only be changed from one type to another. So you can think about many different examples about how energy might be turned from one type to another, but that's a very important rule that I want you guys to understand. One important rule for our society when we think about our energy crisis, when we think about gas prices, when we think about anything that affects, the energy in our world, remember that energy can't be created. So, whatever we have, and we need to make the best of it. All right, and then finally, work and power. So work is when you actually make something move. You apply a force and it goes some distance or displacement, then that means you have done work in terms of our physics definition. And another important thing is power. So if you're able to do that work in a small amount of time, then we would say you're very powerful. Now that definition is a little bit different for physics, but think about power athletes, power lifters. The way they get their name is because they move a lot of things. They move something heavy or they move something very quickly, right? So power lifters do a lot of work in a very small amount of time, and that means that they have a lot of power. All right, so those are just some of the key concepts that I want you to kind of review, make sure you understand. Check the original videos, check your notes, check the practice problems from earlier this year. But that's just like a broad overview of what you'll see on the final and some of the key concepts for the final. Did I bore you? Yeah, I think a lot of my students would say the same thing. All right, good luck.